welcome to another problem session. So here is a really bad problem for any exam, I don't think this is a good problem, but if you remember some things, you can do it. And I don't remember that many things. I can analyze problems quite well, but all this memory stuff is not very good for the physics exams, but that's what it is. So let's look at this problem. So you have, this is coming from JEE 2025, this paper 1, question number 16. So you have two lists, and you're supposed to just match it. And this one has 5, so there's one extra here. Okay, so what's the strategy here to solve this problem? Nothing to work out. It's like energy goes as z square, and z is the, see over here it says z is atomic number, means number of protons. So this is kind of like atomic physics problem. It is from various parts of atomic physics, modern physics chapters. So let's see. This could be several places these things go, and so and this can be several places. This is only one place I know. So let's see. My strategy will just go through this and see if you can map any one of these. So if you remember characteristic X-rays, this is the Moseley experiment. So if you remember Moseley experiment, probably you can just immediately see it. So what Moseley did was he looked at the frequency, square root of the frequency of this characteristic X-rays, like alpha, etc. So K alpha, for instance. So if you just looked at characteristic X-ray there and look at the frequency and plot versus z, not z, but z minus 1. So he had plotted like just the opposite. You would plot this versus this. I just found straight lines. It's like this kind of straight lines. You found like straight lines. Some straight line over here, some different X-rays, okay? So this is like energy. So this is energy. So energy is going as, so this one will say energy is going as z minus 1 squared. So I just remembered it. It's just like, years and years ago I read it, and just maybe as a student I read it, and then this also is seen in a chemistry book. So this Q is gonna go with this guy. So it's kind of like only one, and I'm done. Just C is the answer, and then I can go home. Let's see if I can do other ones. I'm just lucky that this is the only one. Over here, this one I don't know how it will go. Energy of the continuous X-rays, I can guess that one. And is average nuclear binding energy. Oh, this one. So I know this one. Okay, this one I can know, but let me see if this is easier one. Energy of radiation due to electronic. Oh, this one, hydrogen-like atoms. So we all remember that energy in hydrogen-like atoms goes as, actually it's a minus z square over n square. So, and of course, I mean, if you can remember this like minus 13.6 electron volt when this is 1 and this is 1. This must be like z square or n square like that. So this goes z square. So this 5 will go with p. Okay, we did that one too. But if I'd done that one, so I'll have to that guy also. So I still have to do q. R is z times z minus 1. If you remember this, great, but I don't remember that one. Okay, so let's see if this form I remember. So you can say, if you kind of, this is, you remember binding energy per nucleon. Right? Average bond energy per nucleon. If you plot this kind of like a go like this, and it's kind of tapers off, not increasing, it's just kind of, yeah, it kind of tapers off like that. I mean, it's kind of tapers off, tapers something like that, but pretty flat here. So it's pretty flat in this region. And it is saying that between 30 to 170, this versus Z, and this will be like iron or some, iron will be somewhere here in the middle, you know, 56. So it's this range, maybe all the way here, is almost independent. It's in practically independent. It's not independent, but practically independent. So if I were to guess, this would guess, and is correct actually. This is, because we already knew from knowing Q that this is the only one that, and that just basically lucky. I remember Moseley thing. The remember you might remember Moseley is because very important in terms of history of physics and how physics developed at that time. Okay, so I'm not going to take more time on this because this is just memory. You either remember it or you don't remember it. If you remember one of these or two of these, try to rule out as many as you can, and the rest you try to guess based on some physics intuition you have. Next up is paper 2. Till then, okay, bye.